ADAX how-to series. I'm going to link the workshop website in the chat. That's sort of a jumping off point for everything that we're doing. I'm just going to go through desktop capture, I think. Yeah. Okay. Somehow I can hide that. No. All right. So what we are working from is this website. This is the one that I just linked into the chat. If you click on the collaborative document here, it'll take you to this site, which is just a Google Doc. And it's showing you all of the different things. So this is where I'll probably put some notes if there's any mistakes or anything, whether I need to fix up. Like last week where I had the wrong catalog link, I'll put them in here. This is also an opportunity if you want to ask questions. You can ask questions in this document, or if you have things to paste, like a screenshot or something of an issue or a question, this document is good for that. Otherwise, we will use the chat from Zoom, which I'll just open up again and make sure that I can see. And I should be able to hide this thing here. Hide video. Nope. No. Okay. So last week was automating the boring bits. We recorded that session, and there's it's been published on YouTube. So if you want to go back at any point and have a look at that, you can. This week we'll be talking about building on past success. So here we go. So the way that I like to run these sessions, and I found that this has been quite beneficial across all of the different ADAX training that we do, is we work this more like a follow along, code together type session. So I'm going to have my terminal open down the bottom here, and in my terminal, I'm going to have, there we go. I'll be typing all the code and stuff that I do. So I've just got myself a new empty directory that I'm going to be working on today. We're going to be doing these things together. So my recommendation is that you have maybe in a small window, you have the video of this session. Maybe in another window, you have the website that we're going to work through, and then also the terminal for you to work from. Now, this is all easier if you have two monitors. I don't have two monitors in this room, but if you've got two monitors, it's much easier to set everything up. So hopefully everything is large enough that people can read it quite easily. But as I said, all the content is on this website. So as part of this session, what we're going to be talking about is ways that you can build on past success. And to me, what this really means is that the work that you do in research can be repetitive in many different ways. In particular, at the high levels where you have multiple projects that you're working on, you've finished a project, you're going to start another project. There are lots of things that you're going to be redoing. Last week, we talked about automation, about how to make it so that these things could be automatically redone, sort of within a single project. But this week, it's more about how do I use some of the things that I developed for another project into a new project? How can I leverage that existing work for my next project? So that's what we're going to be talking about here. That's what we're going to be working with. So the idea here is about reproducible and reusable workflows. So reusable is where you're using something for for a different purpose. There are many benefits for making your workflows reproducible and reusable. Many of them I have listed here. But at the end of the day, what's really happening is that you're saving yourself time by not having to redo everything from scratch, which makes you more productive, which means you get more research outputs or papers or whatever it is that the goal of your particular work is. And it allows you to either, do more things with the same time or do the same things in less time, whatever is your particular focus. There's also a benefit that once you have developed a workflow and you've confirmed that it's working and that it's doing things properly, that you don't have to redevelop that the second time you use it, which means that you can rely on the correctness of your workflow for the second time. So even though last week's session is not a prerequisite for this session, we're still going to rely on some of the work that we had done before. So I don't expect you to go back through the previous workshop. And in fact, if you were at the previous workshop, I recommend that we start from a fresh directory for this week. So what happened last week was we talked a lot about automation, and we automated the not very interesting process of downloading some data and then filtering that data and making it ready for analysis. So we looked at how to do all of this data cleaning workflow initially just by hand, as I call a workflow for humans. And then we looked at some different tools to allow us to do this automatically. Let me just, so what we came away with at the end of last week was a directory that had all of these things in it. Now, what I would like to do now is just quickly remake all of this structure, all of these files as a starting point for this week. And if we open this little how to make these files, I've just copied them all in here so that you can remake them for yourself. So I'm going to do that. So the first thing I'm going to do is make the directory structure. And as I said last week, I'm going to use my favorite command, mkdir -p, which means I can do multiple things at once. Data, final, data processing, data raw. I also want to have a directory called src. I'm going to leave this .env out for now because we're going to create that separately in a little bit. So this should make those directories. And then I want to make some files. So the first file we're going to make is just called makefile. Makefile. So I'm going to copy all of this. Copy, paste. And then if I press Control D, that'll be end of file. So I should have a file called makefile. And if I open this up, I just want to confirm that these things in here are actually tab characters and not spaces. And that's actually working just fine. So that's okay. So I managed to fix the website so that that would happen. All right, so I've got a make file. And then we need another file, which is our clean AT20G. So I'm going to go into the source directory and I'm going to make clean at20g.py. I'm going to copy all of these. Copy, paste, Control D. All right, got that file. I need a file called requirements.txt, which lives in this directory. Let's just got two things in it. Right, here we go. These two. I don't know why it's doing that annoying closing thing. Right. Copy, paste, all D. Let's see that I got that correct. More requirements. Yeah, that looks fine. All right, so with that requirements file, I'm going to make myself a Python environment. So I type Python -mvenv for virtual environment, and then .env as the directory that my virtual environment is going to live in. And it doesn't work because I need to use Python 3. Now it works. So it takes a little bit of time. And it's now created a hidden directory called .env. And then if I type source.env/bin/activate, I get this little prefix here to tell me that I'm currently working with this virtual environment. So now when I install things, so if I say pip install -r requirements.txt, it's going to install the NumPy and Pandas library that I asked for into this local virtual environment. And it's not going to interfere with any of the other virtual environments that I have. It's not going to interfere with the code that I wrote last week, or maybe the system version of Python that's required to keep my operating system running. All right, so at the end of the day, it says successfully installed, blah, blah, blah. Okay. I don't see anything different, but let's just confirm that I've got all the files that I need. So I've got my environment file. I've got the data file. What's in data? Final, processing, and raw. Good. And what's in my source folder? Clean at20g.py. Okay, so this is what we had last week. And the entire workflow that we developed is in this make file. So if I just type make, let me have a look at the make file again. What are the targets that I've got? Make all. Okay, so I'm going to just type make all. What should happen is blah, 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 a whole bunch of stuff automatically. So we downloaded some data using wget. We filtered the data to put the header. Sorry, this isn't the header. This is removing the header to make our table file. We then filter the header, filter the table using our Python script. And then this last one here is taking the header and putting it into its own file. So if we look in data final, we should see there is a CSV file, which is our final data output, which is all the filtering applied to it that we did last week. And then there's the header file, which just contains header. So this should contain all of the metadata about where we got the table from, what the columns mean, all of that sort of thing. Okay, so our make file is correct. Everything that we've done so far is right. So if you have made all of these files in the right places in your workshop 2 directory or whatever your project directory is, you should be able to type make space all, and it should work for you as it has done for me. If something's not working for you, or if you want me to go back and revisit some of these things, now's your opportunity to ask questions, because we all need to be on the same page before we can move forward. Everybody's okay? All right. Good. Okay, so what are we going to do today? Today we're going to expand on the workflow that we created last week. And we're going to do it in a way that makes it so that this workflow is reusable and repeatable, so that we can not have to spend 2 hours developing a workflow to process a different catalog. So last week, we spent the whole time creating this workflow that just worked on the catalog called AT20G. But we have a few other catalogs that we would like to process as well, and we'd like to not have to spend 2 hours redeveloping this for every single new catalog that we want to add to our list. So this is where we get to the reusability part of things. Make that a little bit smaller. So one of the ways that we can make our workflows reusable is to make the individual pieces reusable. So in the same way that when we type wget and it downloads something from the internet for us, if we want to download different files, we just tell wget, this is the file that I want to download. We don't need to open up the wget script and rewrite it and tell it exactly what we need to do. We've made the script itself accept arguments so that we can change its operation slightly. Okay, we want to do a similar thing for our workflow. So ideally what we want to do is have a workflow where we can say, okay, you've downloaded the AT20G catalog. Thank you. I want you to do the same thing, but for, let's say, the NVSS catalog. That's another one that we're going to be working with. How do we make minimal changes to our workflow to make it flexible and adaptable? So one way we can do that is command line arguments. So for our filtering script, our clean at20g.py file, we can change that so that it uses an argument parser, so the argparse library, which allows us to control the operation of the script without having to know anything about how the script itself works. We can use configuration files. So rather than passing arguments on the command line, we can write a configuration file that says things, for example, this is where the data comes from. This is where we're going to write our output to. These are the processing steps that we're going to do and some of the methods we're going to use. So we can have a configuration file that is read by our Python script. So then in order to change the operation, we just go and change the configuration, which is a bit more human readable than having to change the Python script itself. Now, these are both very good ideas, and an even better idea is to do both at once. And so there's a Python module called config argparse, which will do both of these things at the same time. So it allows you to provide a configuration file, such as the one that we've got here, but it also allows you to provide arguments directly on the command line. So this is sort of the highest level of flexibility that we can get with the minimum amount of effort. So for example, we could run our script by just putting everything into the configuration file, or we could do a combination of read things from the configuration file and override things from the command line. Of course, we can also do things without even using the configuration file. So this config argparse is going to make it much easier for us to modify our script to work on multiple different catalogs. So how does that work? Well, this is the script that we have at the moment. This is a very direct script. All of the code has been written in the global scope. It's very procedural and it will always do the same thing. So what we want to do first is to generalize this script. So we're going to make it so that the input and output tables are configurable. We can tell Python, don't always read from this location here, but allow me to pass you the name and location of a file to read from, and let me pass you the name and location of the file to write. So that's one thing that we want to do. The other thing that we want to do is allow the user to specify the delimiter. So here we've said that the delimiter is always tabs, but maybe people are going to read in CSV files, and so the delimiter should be a comma instead. We want to determine which columns should be kept or removed by using user input. So at the moment, we've just hard-coded that these are the columns that we need to keep. It would be nice if that was configurable as well. And we'd also like to keep all these options in a configuration file so we can figure out how the script was run after it has been run. So in order to do these things, and we won't do all of these today, but we'll do many of them, we need to rewrite our code a little bit so that we've kind of got two sections. And I think of this as the configuring section and the doing section. And the way that we separate them in Python is that we have an if name clause and we have a main function. So what that looks like is we make these very minimal changes to our file such that when we run our file, it will come down. Well, firstly, it defines what the main function is. And then it comes down here and says, okay, this script was run from the command line, and then it runs the main function. And that allows us to put in here all of the configuration stuff that we're going to do in a little bit. Okay, so let's start off with that. So I'm going to work on the source/a clean at20g.py file. And you'll have to forgive me because I'm not super good at using Vim. So for example, I'm just going to have to manually put all these spaces in, which is annoying. Just to do all this indentation here. So all of this code is part of my function. So I should write return because that's the end of my function. And then I'll do if double underscore name double underscore double equals double underscore main. If that's the case, then just run my function called main. And Vim is using it's using 4. I guess I'll do 4 indentations for everything just to be pedantic. All right. I know there's a way to do this faster in Vim, but I don't remember the shortcut for it. Okay, so there we go. I've got everything. Yep. Okay, that looks good. So we've now got we've made no functional change to our code. It does exactly the same thing as it did before. It reads the same input, does the same work, and writes the same output. We've just reorganized the way that things are managed within our program. So some of the work that is done in our scripts is specific to the AT20G catalog. So for example, here where we're choosing which columns we want to keep, that is specific to the AT20G catalog. But other work is more generic. So reading and writing, so long as we can update the file name, reading and writing is done in the same way for all of the catalogs that we're going to work with. And also maybe some of the filtering that we're going to do here. So filtering things based on the RA range. That part of it, this line here, is probably going to be the same across multiple different catalogs. And so what we want to do is write separate functions for each of these pieces of work. Now, we could write a separate function for each catalog that we will use. So here we've got a main function that's just for the AT20G. We could write another entire function that's just for NVSS, and another function which is for some other catalog. Well, that would mean that we effectively writing things from scratch, and that's not really saving us time. That's defeating the purpose of what we're trying to get to here. We could write a single, very flexible function that will handle any catalog so that it has all of the options as to where do you get your catalog from, which columns do you want to convert to floats, how do you want to replace your strings, how do you want to do the masking, which columns do you want to keep, all of these things. So we could have one function that has many, many arguments passed to it that would be very flexible. That would be a little bit of a pain to write and be a little bit less easy to use. So what we're going to do is actually take the middle path. And to take the middle path, we're going to make things as complicated as they need to be for now, but allow for future changes to make it more complex if needed. So the first few things that we're going to do is change the file so that the load and the save functions are separated. So you just tell it a file name and a delimiter for loading, and the given table and the file name for saving. And we're going to have a function called clean at20g, and you just pass it an already loaded table. So we're going to divide our main function up into three individual functions. And we're going to save this as a new file, a generic file called clean tables. Okay, so let's start to do that. vi source clean. All right, so the first thing I'm going to do before I forget is write this. How do I do that in Vim? I forgot how to do it in Vim. I'm just going to copy the file. Source clean at20g.py source clean tables.py, and then I'm going to edit the clean tables.py. All right, good. So this is my copy file. So I had said that we want to create a function called load, and this is going to take a file name and a delimiter, and going to return some table. And then another function called save table file name, and it's going to return nothing. And then another one, which is just called clean at20g, which takes a table and returns a modified table. All right. So let's, rather than having to figure out exactly how to do all of these things, what we're going to do is really just take pieces of our existing function. So the read the table part, this part here, I'm going to copy that and I'm going to put it into here, into the loading of the table. So we're saying read the table, but instead of being that name, it's just whatever the file name is. And the delimiter is the one that the user provided. Not return the data frame, okay? And then here, instead of calling this code explicitly, I'm just going to call this one here. So load that and delimiter equals t. Okay, so that's a bit of a, maybe this feels a bit pointless. I haven't really saved myself any lines of code. I've actually added lines of code, but now I've got a load function. If in the future I need to figure out to change the way that the function loads files, I can change it in here instead of somewhere else. And so this is going to give me my data frame. Now I can do a similar thing. Let me just make sure that I'm not doing silly things. Okay, I did a shortcut here. That's fine. All right, so we're going to go down to here and we're going to copy this bit. Okay. in here. And it's not called dfx now, it's called table. To CSV file name. And we still don't want the index, so I'm going to leave index as false there. And then down here, instead of this, we're going to say save, and then that. Save to that file name, but the table that we're saving is called dfx. Okay. Then what are we going to do? And then we do this clean AT20G. So the clean AT20G actually takes the place of our main function. Okay. So we've broken this up a little bit. The loading and the saving is now generic. Instead of our main function, we call clean AT20G. And we do this because maybe in the future, we're going to have another function instead of this one, which is specific to some other catalogs. Okay. Oh, I've done it even smarter here. Okay. Let me undo this bit. So when I clean the table, yes, this should, yeah, accept the table. All right, so let's insert in here. Take a table, and this will be table.replace, blah, blah, blah. Everything's fine. And then I'm just going to return dfix here. Delete, delete. And then down here, what we do is we say, let's table equals load, and then the name. Data processing AT20G table.tsv. Delimiter equals tab. Then we clean the table. So we replace the table with a cleaned version, and then we save the table to data final AT20G final.csv. Okay. All right, I'm happy with that, so I'm going to save it. I should probably test that this works. So let's do make clean to delete all the files that we downloaded, and then do make all and see if the Python script runs. So this Python script, oh no, it's calling the wrong Python script. So let's change our make file so that it doesn't run that one, but instead it runs clean tables.py. And then we will say make again. Oh, sorry. All right. I also need to change this. So this way, if I change my clean tables script, it will still rerun this. So let's save that. And if I take make all, it should, nothing to be done. Okay. Make data final AT20, AT20G final.csv. Just do that for me. It's up to date. Fine. Python source clean tables. So this should just run. Okay, so now it's running. All right, so we've now got a script that is, it's still doing the same thing, but it's in a state that we're more easily able to edit and modify. So we're now going to modify this again so that it will work with config argparse. So we want to have config argparse accepting input and output file names as arguments, and keep the existing behavior of our code, by making it the current hard-coded values default. So what that means is we're going to have to import config argparse, and all of these functions here stay the same. We just add this extra bit here that tells config argparse what arguments we're going to accept, and also give them some default values. Okay. So let's do that now. So let's insert a import config argparse. And then down here, give us a bit of space to work with. Now, so that I don't make mistakes, what I'm going to do is actually copy all of this stuff here. Excuse me. All right. So what this is saying is give me an argument parser, and by default, look for the configuration file is called config.yaml. We might not actually use that YAML format, but it doesn't matter. We add some options. The first option is the configuration file. So this is how the user can pass it in. We then have another option here, which is either -i or -- input file. And this is, as it says here, the path to the input file. And we're going to give it a default value, which is data processing AT20G table.tsv. And similarly for the output file, we're going to give a shortcut -o and a long cut -- output file. And that's going to default to what our existing script is doing. And then similarly for the delimiter as well. So what we do when we set up that parser, we say parse args, and then this args variable here holds all of our arguments. And so we can do things like say args dot input file. And we can say args dot delimiter. And then here we can say args dot output file. Okay, so what this is doing now is saying if the user doesn't add anything on the command line, then we're going to use these values here, which is what we did before, but the user now has the option to change input file, output file, and delimiter. Okay. How's everybody going? Does anybody have any questions? Are you encountering any problems? Everybody's okay? Okay. All right. We shall proceed then. So something that we've done here, so let me save the file. And if I run it again, Python source clean tables.py, if I didn't make any sense, no module name config argparse. All right, I made a mistake. So what do we need to do to fix that? We need to install it. So I'm going to say pip install config argparse. And it's going to choose version 1.7. So what I should then do is edit my requirements file and say, please also install config argparse version 1.7. So I'll put that in my requirements file so that if I come back to this project or if I move it to another computer, I can still run my scripts because I'll have all of the requirements installed. So let's type again, source clean tables.py. Everything seemed to have worked. If I type dash dash help, it will tell me these are all the options that I can use. So dash H or dash dash help, this is, I didn't have to add this. This is automatically included. It tells me all of the information. It also tells me a bit about what the double dash arguments mean and how I can specify them either in config.yaml or in a particular file using dash dash config, blah, 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 blah. And then it gives me a short link to the actual documentation for config argparse. So that's pretty nice. That didn't really take us much effort at all. And let's see how we go. Yeah, so we've got the help file. We could test this out. Instead of saying help, I could say the output file is out.csv. Runs, and it produces a file called out.csv. So that's good. That's working the way I want it to. Don't want that file. All right, so now we've got a workflow or a script in this case, which is configurable. We can adapt it for use. So let's figure out how we're going to configure it. So let's have a look at the NVSS data set. So this is the next catalog that we're going to look at. The data is at that location. Okay, so this is what the file looks like. As with the AT20G one, we've got all of these hashes at the start, all of these comments, which is metadata about where this catalog came from, what the different columns mean. We also have this annoying feature where we've got column names, and then we've got each of the columns have a particular format. And then below that, they've got these dashes to separate the header of the column headers from the column data. So we're going to have to deal with that in the same way that we did with the AT20G survey. But you'll see here now that we've only got a couple of columns that we're actually interested in. So in this one, we're interested in the column S1.4 and ES1.4. So that's a measurement and then an uncertainty. And none of these have any missing data. So we don't have to worry about filtering out missing data in this particular one. If we wanted these columns over here, then we'd have to care about the missing data, but we don't want those columns. We don't want whatever this is, E-min access, E-maj access. We don't care about that. We just care about these S1.4 and ES1.4, which I think is actually this column and this column here. Okay, so that's what the data file looks like. They're the changes that we need to make. So how do we change our workflow and what parts do we need to keep the same? Well, I said that the header works in the same way, and we've got the same column headers, column units, and dashes here as we did with the AT20G. So that part of the processing workflow can stay the same. We've got columns like underscore RAJ2000. We've got this glon, glat as well. And we've got columns here, S1.4 and ES1.4 that we want to keep. So let's see what I said here in terms of the changes that are made. So loading and saving is going to be the same between them. And we still filter on the same column. Some of the processing is common, but needs to be done slightly differently. So the list of columns to keep is different. And some of the processing isn't needed for NVSS. So we don't need to drop the rows with blanks, and we don't need to convert the data types for some of the columns. Those two are related to each other. So that's why we don't need to do each of those. Just make a quick note for something that I forgot. Clean. tables. Yeah. All right, so what we're going to do is we're going to make some more modifications to the clean tables file. We're going to have a function which is drop NA, which converts strings to nans and then removes those with blanks, the rows with blanks. A function called convert columns, which converts the given columns into a float format. We have a function called filter rows, where you just tell it the column name and then the min value, max value. And then we have another one called keep columns, which removes all of the columns that are not in that list. So once we've done this, once we've added these functions, our AT20G function can start to use those. Okay, so let's have a look at how we did that. So load and save is the same as before. We've pulled the drop NA code. So we've just copied this code to a different place in our file and put it into a function. The convert columns is for every column that is in this list of column names, we just convert that into a data type of float. And the filter rows, we've got the same thing before where we created a mask and then we masked our table, except this time the column name and the minimum and maximum value are now parameters that we can change. And similarly with the keep columns, we're just essentially saying, give me only the particular columns that you've asked for. And that means that our AT20G file is one line at a time, loading the file, dropping the, converting and dropping rows which have these columns as blank, converting these columns to be float format. Here's the filtering. So we've said, here's the column name, and here are the minimum values, 12 hours and 18 hours. And then keep columns, which means keep only these things here. So if you look at that AT20G file compared to the one that we have at the moment, sorry, looking at the function, clean AT20G function, you can see that all I've done is I've just taken each of these things and moved it into another another function. And in fact, then what I've done, I've also changed down here, instead of doing the loading outside of the clean AT20G, I've moved that inside the clean AT20G. So the clean AT20G function just says, here's your input file, here's your output file. Very nice and easy. Yes, cool. All right. So let's make those changes, and I'm going to do it in clean AT20G. Why did I duplicate that? Let's not duplicate that. Let's add in these extra functions. So these are the functions that I want. Copy, paste. And now I'm going to change this one so that it looks like, actually I have to copy all of it. Okay. So now all of the work gets done within the AT20G function. I can delete the old one. Bye-bye. And then here, all we need to do is say clean AT20G. We don't pass it a table. We give it args.input file and args.output file. Okay. So what you'll see at the moment is I've got I've also added an extra argument on here, which is to be AT20, the survey. All right, I guess I better put that in as well. So this is something I was kind of preparing for future use. So now what's happening is, just delete that. We have the input file, the output file, and the delimiter are specified on the command line, and also the survey can be specified on the command line. But initially, we're not actually using the delimiter or the survey. Someone has a question. Oh, okay, not a worry. You can watch the video to catch up on the rest of what we were doing. Okay, so I added some options that we're not needing because the AT20G, we know exactly what's going on. So yeah, we'll see how that works in a minute once we start working with the NVSS. So now we can use our newly created functions to create a clean NVSS function. So now anytime you see these dots, this is just me not repeating the whole of the file because the file's getting pretty big now. So now what we can do is we can have a clean NVSS function, which just takes the pieces that are needed. So it needs to load the input file, and it's a tab delimited file. We need to filter the rows for RA, and we need to keep columns. And this time the columns we're keeping are all of these positional ones, something here, which is the name of the source, and then these two here, which is the measurement and uncertainty on the flux density. And then we save the table. Okay, so in order to process NVSS, I don't need to create any new smaller functions like the detailed working functions. I can just build this clean NVSS from existing functionality that we had from the AT20G. Now, the other thing that I do down here is we now look at this survey option, and we say, if the user told me that it's the AT20G, then I'm going to use the clean AT20G logic. If it's NVSS, I'm going to use the clean NVSS logic. And if it's something else, I'm just going to tell the user that I don't know what they're doing. Okay. So let's put that into our function. So let's say after we've done the clean AT20G, we're going to also do clean NVSS. Paste. And then down here, instead of doing that, we're going to do all of these things here. And then paste into here. All right, so if the survey in uppercase letters is AT20G, do this. If it's NVSS, yes, okay. So what will happen is if I say that the survey is NVSS, I should actually tell it a different input and output file because by default, it is the AT20G that's being used. Okay, so I've got to remember that I should do that. So what have we done so far? We've done the following. We've downloaded the NVSS data set. We inspected the new data to determine what processing is needed, updated our Python script to include the new filtering steps. We haven't made this run in its entirety yet, though. So we need to update our make file so that it works for the NVSS catalog. So this is where edit the make file. So if we see here, we've got this pattern. This is saying we're going to, if we say all, it's going to do the AT20G stuff. Now, I'm going to rename this to be AT20G. And then I'm going to make a new one called NVSS, which has got some similar stuff. And now all refers to do both AT20G and NVSS. Okay, so I'm redefining what all means. And I'm also going to do a thing here, which is working with a parameter called phony. So if I click on this, it should say, yeah. So now what we've got here, we've got this first line that just says phony, which is telling make that these are not actual files that are going to be created. So if I was to run this workflow and I had a file in my local directory called all, then Make would say, you've already got a file called all. I'm not going to run your workflow. It's a small bug that happens sometimes. But if we tell Make explicitly that these are not real files, then it's not going to look for files with these names when it decides how much of the workflow it's going to run. All right, so now I need to define what are the NVSS targets. Well, they're the same as the AT20G. We've just got NVSS in their name. And then essentially everything that I'm doing here about the AT20G files, I want a way of doing this again, but for the NVSS files. So this is an opportunity where I could come through and say, draw some magic functions here that would replace this AT20G with some regex or a make magic. But I find these really difficult to read when you're coming back to the file in a few days. So really what I would do is I'm actually just going to, well, what I'm going to do is just copy it out of here. But the way that I created this is that I copy and pasted where's it gone? This one. I copy and pasted the AT20G stuff and then just did a search and replace of AT20G with NVSS. So that's what I would do. But for now, I'm just going to copy this. So if I wasn't using Vim, I would do this. In fact, I'm going to put a little note to myself that this is all of the AT20G stuff. And then that this one is all of the NVSS stuff. Blah, 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 blah. Okay. So now you can see when I'm calling AT20G, I could leave all of the defaults, but I'm not going to. I'm going to be a good user, and I'm actually going to explicitly say what I want the inputs and outputs to be. So using my config argparse, I can say clean tables, use the methodology for AT20G, input should be this file and the output should be that file. I come down here and I do very similar things for the NVSS in terms of how we do all of the processing. All the rules are effectively the same. And then for making the final one, I say, use the rules for the NVSS survey. And then the data processing, the input file is this one and the output file is that one. And then I need to remember to clean up after myself. So do this so that when you say clean, it actually deletes all the data files. So now I've got a make file and I should be able to say make NVSS. Let's see how it goes. It's downloading the file. It did the grep. It did the cleaning. It did the header. So now I should be able to say ls data final. And I've got the NVSS CSV. Let's just look at the head of that. Yeah, cool. Okay, I've got the columns that I'd asked for, and it's in a CSV format, and I don't have any of the header or any of that sort of stuff. And if I look at the header.txt, I've got all of this metadata stuff. Okay, awesome. So that took about 1 hour for me to do all of this work to make the second survey work for us. And most of what I was doing was just expanding our original scripts, making them more flexible. So the first time I did this, it took us 2 hours. And the second time it took 1 hour. Now, how long is it going to take for the third time we do this? Hopefully it's not going to take half an hour to do. And so the next survey we want to work on is one called sums. Now, before we do that, let me see if there are any questions that people have or any difficulty that you're having so far. So far, so good. Okay. All right. So the next thing that we need to do is we're going to have a look at the data for the sums survey. And that should have loaded up here. Let's get this out of the way. Yes, this is the sum survey. Let's put it over here for now. All right, so sum survey. It's got the same header. It's got the same column header, column units, a bunch of dashes, so we know how to work with that. The data that we're interested in here is SP, so it's the peak brightness at this frequency, and then error SP, ESP. And those two columns, unfortunately, these are tab delimited. I think those two columns are these ones here. And they don't appear to have any spaces or null values in them. So that's good. So everything that we need to do to this catalog is something that we've done to the AT20G or the NVSS catalog. And that's going to allow us to save a lot of time. So in our Python script, we just add a new function that's called clean sums. And this bit here is mostly just copied from the NVSS one. And all we really needed to change was these values in here to say which columns we want. Does this one specify a name? This one does not. That's a field name. No, okay, it doesn't. So that's all we really needed to do. And then we add an extra args to say, or another clause in here to say, if the user says sums, then run this function and give better, slightly different help on the output. So the amount of changes that we're needing to make to each file now is becoming less and less. So let me add this to our Python script. So let's go to source clean tables.py. After the NVSS, we should add in the clean sums. So it's still tab delimited, filter the rows based on the same conditions, keep the columns, save the output. And then down here, we're going to delete these two lines and we're going to add these lines here instead. So, no, don't do that. That's what I want. So else if sums do this and otherwise choose from those. Okay, so didn't need to make very many changes there. Save that. Of course, we need to change our make file again. So this time, the make file, we're going to add another section here, which is going to be sums. And we're going to add something, tell it that that is phony. And then all means that we do all three of these. So what's this going to look like? Data final sums final .csv, data final sums header.txt. And then again, I could copy and paste all of the stuff from NVSS and do a find and replace. But because I'm not a very good VI user, I will just copy paste what I have here. So I don't know the shortcuts. All right, so for the sum survey, let's add all of this in. And then I have to remember to clean up when asked. Okay. So let's see, clean tables. So here when we run clean tables, we're saying use the logic from the sums survey, use this is the input and this is the output. So let's save that. And then let's see if we can make the sum survey. Has this worked? it has run without causing an error, which is usually our first indication that we're okay. But let's have a look at the table. Where's our CSV? This one. Have a look at our CSV file. Hey, that looks pretty good. Let's have a look at the header that should have been split off from the original table. Yeah, that's working well as well. Okay, cool. So we've now got a workflow that will work for all three of our surveys. And you can imagine that from now on, adding additional surveys just means doing this process again, copying this, doing a find replace for sums to whatever the new survey name is. Maybe you're getting it from a different file. So you might update this URL and then making a new thing in our Python script. So adding the sums processing took us less than 10 minutes to do it the second time. So we went 2 hours, 1 hour, 10 minutes, and from now on, it'll probably take even less than 10 minutes to do. We're not going to add any other surveys because it's a bit pointless at the moment. But what will happen is every time we come in here and we say clean sums, clean NBSS, we're having to add extra functions specifically that says clean this particular survey using predefined rules. Now, this is the point where if I only have these 3 surveys to work with, maybe I'm done and I can just move on to other parts of my research. But if I know that I've got another 20 or 30 of these things coming up, this is where I don't want to have a huge, massive tree of if-else statements for every one of my surveys, and then every one of my surveys having a very similar thing here. So this is where I might look at, for example, the difference between the sums, clean sums and a clean NBSS, and realize the only difference between those two was the listing of which columns to keep. And so maybe I'd want to make my command line arguments a bit more expansive so that you could say, here's the file to read. Here are the filtering options as to which column you're going to filter on, what the values are, the min-max value for that, which columns you need to keep, et cetera, et cetera. You can have all of this specified via the command line so that you don't need these if-else statements. You just need something that says, run this function with these arguments, run this other function with these arguments. So that's where you would have the sort of ultimately flexible filtering script, which again, you would only do if you knew you needed it. And then when you're running, you'd still have to write these things in your make files, but here, instead of saying survey as sums, you would just say input, output, filtering on column RA, min value, max value. These are the columns I want to keep, that sort of thing. And even though this might look a bit verbose in here, the fact that we can use a configuration file means that we don't even need to put all of these things into our make file. In fact, we can just put all of the configurations into our config file. So let's have a look about how we could use our configuration file. So we can call our filtering program using this. So using all of the options from the command line, or we can use it by telling it there is a configuration file that I want you to read from. So let's now start to make some of these configuration files. So the format of the files that we can use is just, again, comments, start with a hash, and then we're going to say option equals value. Okay, so here where we say -i, we would say input file equals, and then the path to the input file. Okay, so let's make a file that's called at20g.config, and it would look just like this: input file, output file. We could say delimiter, even though we don't actually use the delimiter there. In fact, what we should say instead of delimiter is survey. So let me make one of these. So let's make a new file called at20g.config. And then let's edit that. So we'll get the input and the output, because that's what we need to use. But also we need to say at the moment, survey equals AT20G. All right, so that's what my config file will look like. So just note that I need to update this. I'll make a note for myself. All right. So these are the options that we would have put on the command line. Survey equals AT20G, input file, output file. We can put these in any order. It doesn't really matter here. And then I can run Python clean tables.py. Config is at20g.config. And it would read all the configuration from that file, do all of the processing. Now, at the moment, our script doesn't have any output, any text output for us to see what it's actually doing. So not much we can do there. We could confirm that the files have been overwritten, but I trust this to say that we've read all of the configuration from our config file. Now we can do the same thing for NVSS and sums. And what I recommend is that instead of having a whole bunch of .config files sitting in your root directory, is that we make a new directory for storing all of these. So I would say, let's keep all of our configurations in a configs thing and move at20g.config into that directory. And then we would do the same thing for NVSS and sums. And let's see. All right, I need to make the files. All right. Yeah, okay. Configs, nvss.config. What are the options that we need there? So if we look at our make file from earlier, we can see that we had survey equals NVSS, input file equals this, paste, output file equals this one, and control D, and then configs sums.config, and then similarly survey equals sums, input file equals, oops, I think I made a mistake on the other one. I did, I made a mistake there. I'll fix that in a minute. For sums, the input file is this one. And the output file is this one. Let's edit that one that I made a mistake. So here, I just need to put VSS. That, okay, fixed. So now in my configs directory, I've got these three things here. So this means that when I want to update my make file, update the make file. Yeah, change to the relative option. Okay, I was a bit lazy there, but anyway, make file. So let's see, where are we? Sums. So all of this here, instead of putting all of these arguments, what I can instead put is config equals configs. I don't put an equal, sorry. Configs sums.config, delete all the rest of this. And I should probably also make it so that if I update my configuration, this part of the process will rerun. So I'm going to put configs sums.config as a requirement for this recipe, which means that if I change my script or I change my configuration, then this recipe will run again. Okay, so go do the same thing for MVSS, configs, mvss.config, and -- config, and also for AT20G. Okay, so what this means now is that I don't need to look inside my make file to see what the options are for the different surveys. If I wanted to change my options, I could change it just by looking in and editing the config file. So that means that my make file is more describing the workflow as a whole, but the actual detailed configuration of the workflow can now be controlled by me looking at this configs file. Okay. All right. Let's make sure that this all works properly. So I'm going to run make clean. You should delete all of those things. I'm going to say make all. And if I cross my fingers and didn't make any silly mistakes, this should work. Downloaded all the things, doing a bunch of stuff. Clean tables, unrecognized arguments, input file. Oh, see, there we go. Here's a stupid mistake. Input file. Right. Yeah, this is the sort of things that I do sometimes. So let's, oh, it's not even in there. It is in the configuration. Sums.config. Input. Don't want that. And if I type make all, it'll just make the things that broke last time, which was that. Okay. So now we have a workflow that's nicely automated. If I wanted to change things about it, I can change the sums.config. If I had many more surveys, I would know to go and change my clean tables script to be more generic, more flexible. But for now, I have exactly what I need. All right, how's everybody doing? What questions do you have at this moment? No questions. Okay. All right, so I kind of touched on this before, but when I ran my make thing, it's kind of threw a bunch of stuff on the screen here for me, but this wasn't very useful, and it's all ephemeral as well. If I log out of my computer and come back, I can't see all of this text here. So if I wanted to know, say I've downloaded, I've processed all of these, done like the pre-processing, filtering, whatever you want to call it, for these 3 surveys. And then one of my colleagues comes to me and said, did you include this column, or does this survey have this column in it to start with? Or what were the options that you used for the filtering of this particular survey? Now, I could look at my make file and configuration and kind of backtrack and figure out exactly what was done, but that's a bit tricky. And as you have larger projects where you've got more and more pieces, that need to join to each other, it can be pretty tricky to trace back and figure out exactly what actions were taken on your particular data set. And so it's a good idea to have a workflow that tells you what it's doing as it's doing it. And so this is where documentation and reproducibility go hand in hand. So what I'm recommending here is that we build a workflow that documents itself. So a sort of self-documentation. Now, some of the things that we would want to keep track of is what is the workflow doing at a high level? What's its purpose? We would want to know what version of the workflow has been run on our data. We would want to know where the data came from in the first place. So where did I actually download these data from? And which Python environments were used, all of these sorts of things. So there's a lot of detail there that is a little bit painful to keep track of manually. And so we're going to look at some automated ways of keeping track of this data. So really what we're going to focus on here is this documentation side of things and keeping our documentation up to date. So I'm not talking about the kind of user documentation, which tells people how to use your data and how to use your workflow. That is something that you should do in a readme.md file. I'm talking more about the documentation that goes with the data, or what people usually refer to as metadata, that tells you about how you got to the data. So here's some ideas for some self-documenting workflows. One of the things that we can do is we can use the logging module from Python, so that each time you do something, you are writing an entry into a log file. So in this case, myscript.log, so that you can see without having to look in the configuration files, you can see a narrative of how the data got to be in its present state. Another thing that's useful to do is capture the software versions of the software you're using as part of your workflow. It has happened to me multiple times where somebody has read an article somewhere, or they've encountered a problem themselves and they've said, this particular version of NumPy or Pandas or whatever, it's got a bug in it. Has your workflow been using that version of NumPy, or is everything okay? And it's very important to me to be able to know the answer to that, because if I don't know the answer, then I probably have to reprocess all of my data just to be sure. And that can be a tedious and boring process. So doing simple things like saying, these are the versions of NumPy and Pandas that I'm using. Probably 99% of the time, you're not going to look at that information. But when you do need the answer to that question, it's very valuable to have it on hand. The other thing we can do is have metadata that is stored along with the table itself. So we saw this earlier. In fact, we cut a lot of it out earlier, which is the metadata for our raw table. That had all of these hashes, and it had this big list of, here, I'll just show you here, all of this stuff here, all these hashes. These are all the metadata associated with this data file, with this catalog. We can create metadata that is specific to our workflow. So there's the original metadata, which is how the catalog was constructed in the first place. Then there's the secondary metadata, which is specific to our workflow, that says how we modified it from its initial state to its current state. All right, so we're going to start to make a self-documenting workflow. And really all this requires is that your workflow or your various scripts that you're using are going to start to use either the print function or ideally something like logging.info to tell the user what you're doing during script execution. So what we want is to modify our Python script. And this is how I suggest that we do it. is that each time we enter one of these functions, we just have a logging bit that just tells us essentially what tells us that the function was called and what we were doing each time. Okay. So let's have a look. We're going to start with setup logger. And I've put little dots here, which means you should copy the thing from before. So let's have a look back to where we copied that from. Here we go, setup logger. All right, so we're going to clean tables.py. And we're going to import the logging function. And we're going to give this particular script a version. So I'm going to say this is version, why not, 1.2.3. Doesn't really matter. And then what I should do is every time I make a change to this script, I should change one of these numbers here. I should increase them, okay? So this is just saying this is the version of my script. I'm going to paste in this setup logger function. Why is that indented? I don't want that indented. Okay. So what this is doing is saying, I want the logs to be written to something called myscript.log. And then I set up the basic configuration, which says we've got the file name is just the one that's already given. In fact, let me add some spaces in here to make this a little bit easier. The logging level is information. So only things that are information or more important are going to be logged. Anything that's logging.debug won't be written. Here is the format. So this is the time, info, warning, that sort of thing, the level, and then the message. And then there's also a date format for the time. So that's just setting up our logger. And then for each of these, so in the load file, I would write something like logging.info. Reading table from file name using okay. So just at the entry to each of these things here, I'm going to write something like this, saving table to okay, drop NA. What have I suggested here as load, convert it? Yep. Okay. In fact, this help here tells me what we're doing. So let's say logging.info, dropping blank row, blank values from column names. I guess that should be columns. Convert columns. 13. Okay, filter rows. Filtering column. Keep values with min val or name. And I should put the exact logic in here so that there's no filtering rows is actually what I should say. Filtering rows to keep values with min value, call name, max value. Keep columns. So keeping only columns. And being AT20G. Okay. All right. So in a little departure from the knob, I've actually suggested that down here we say applying rules from blah, blah, blah. Okay. Logging.info, applying rules from AT20G. Now, my little OCD brain tells me that I should have put this inside the other function for consistency. I've already committed to this, so I'm going to do it this way. But if I had to do it again, I would probably write these logging things inside the other function. But the important thing here, applying rules from sums. The important thing here is that the user is getting feedback. So let's say the print, instead of printing, we'll just do logging.info. Okay. I think we're done with that. So if I now run Python source clean tables.py config is configs, let's do at20g.config. Now I should get errors. Okay. Min val, I was typing too quickly. Min val should be min value, I guess. Yes, min value. Run that again. Where's my logging? Oh, it went to a file. No, didn't go anywhere. What is happening here? Oh, I know what I did wrong. I need to set up my logger. Okay, so let's run that back down here. So I parse, do all that sort of stuff. And then in here, say setup logger. And this is going to be the log file name is clean tables.log. Okay. All right. Now when I run this, it tells me nothing, but I have a log file, clean tables.log. And it tells me here, so this is the time and date when it was run. This is the level of the message, the information message, and it's telling me applying rules from AT20G, reading the table data from here, using delimiter equals, you can't see it, but that's a tab character. Dropping blank values, converting columns, filtering rows, keeping only columns, saving table to the data, to this location. So now you can see if I put this log in a directory, yeah, if I put this log with my data, then I've got myself a nice bit of metadata that's describing exactly the processing that went into creating that data file. Now, I could make a new directory called logs, or I could save this log as, let's say, at20g dot metadata or something like that. Maybe that's something that I'd want to do. I have to think a bit more about exactly where I would want to save that. Okay. Now, I don't remember whether, oh, I guess I can test it. Just trying to see whether this is going to append to the file or whether this is going to overwrite the file. It appends to the file. Okay, good. So that means I can log. I can do make clean, make all, blah, 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 blah. does all the work. And then at the end of the day, I should be able to say clean tables.log. And then it will tell me, here we go. Applying rules from AT20G did all this work. And then doing things from NVSS. And then doing things from sums. So now I've got a history of all of the work that was done on these particular catalogs for my workflow. It's telling me what's happened. In fact, it's only telling me what's happened in one part of my workflow. There's still another part of the workflow that I haven't documented yet. We'll get to that in a little bit. So how's everybody going? Still keeping up? Any questions? No questions? Okay. All right. So this is another thing that we can do, is we could modify the clean table so that when we save the data, we also write the metadata to the heading of that file, or not to the header really, into the, I guess it's the header of that file. So here's a little Python snippet that will do that for us. So when we save our table to a particular file name, firstly, it opens the file for writing. And then if we've provided metadata, we write that metadata, and then we write our table as a CSV file. So if we do that, let's see, here's my suggestion. So let's modify our save function. So source clean tables.py. Let's go up. Where's my save function? Here it is. Saving table to, okay, I'm going to keep that bit. And I'm going to add this stuff here. And this needs to, like that. Okay, and that needs to be indented like that. All right, so, and we end up doing metadata equals none, which means you don't have to provide metadata if you don't want to. It will skip this bit. All right, and then we can use this later on to generate our metadata. So here I've suggested that we have date time imported so that we can tell when this file was generated. So let's go back up to the top again. Let's from date time import date time. Don't ask me why they make you do it that way, but that's how it is. And then I'm going to put in here, where am I going to put this? Save. A little bit done. I think I might have to pass the metadata in here somehow. That's okay, I can do that. So firstly, we want to calculate what the metadata is. So my suggestion here is that the metadata is generated by, so we know which script made it, the parameters that the user passed into the program, the software version, some of our dependencies. So we use the version of pandas and the version of NumPy. We list what the filters were done. So here, I don't want those actually. So the filters are this and yep, and then the time that it was generated. That's the metadata. So I'm going to change these so that you can metadata. Metadata. And then I have to change each of these things here so that they accept metadata equals none, which means by default you don't have any. And then the save commands inherit that as well. Okay, that should be all of them now. So the metadata gets passed into the cleaning function, does all the cleaning, and then it eventually goes into the save function. The metadata is all here. Get passed into those functions. Okay, so let's now, if we say make all, because I changed that script, and that script is a prerequisite for the final survey underscore final.csv file, make should remake those 3 files for me. So there we go, they're being remade. And if I have a look at data final sums.csv, we can see we've now got, it's generated by, here are all the parameters. So I can see what those parameters look like, the input file, the output file, the config file, the limiter, all of that sort of stuff. Software version, dependencies, so the versions of NumPy and Pandas, and then the date that it was generated. And where is my, something's gone wrong with the header. I don't know what this information is. That's the wrong information. All right, I made a mistake somewhere. I'm not sure what mistake I've made there, but anyway, the column headers have now disappeared from my table, and some of the information has been truncated. So something's gone wrong there. I'm not quite sure what it is. I don't want to try and debug it right now because we don't really have time left. But no doubt I've messed something up in this function here. I'll have to double check what's going on. I think I probably just need to flush that thing. But anyway, like I said, so it's almost worked with a small caveat that I've made a mistake. We'll call that a success, and I'll update this website probably this afternoon or tomorrow to have all of the correct information there. So let me just make a note. Okay. So this is another way that we can add all this information, all this processing information to our to the data files themselves, so that all of those questions about the, what would you call it, the history of the data file, of the how you got to that location, how you got to that state, is automatically captured for people to use in the future. All right, the last thing I wanted to note, and this is just something I'll note, we're not really going to implement this today, is that within our make file, we can also do some logging as well. So for example, we could define a variable called workflow, which is the workflow log.txt. And then each time we do something, we add this little echo command, which just says, we're doing this, put that into the log file. And so these commands that say echo here with a little at the front of them, this actually means don't. So normally what make will do is it will print this to the screen and then it will execute it. If you put an at the start, it won't print it to start with, it'll just execute that line. So weirdly, this at means don't echo this to the command line for the user to see, but do echo it into the log file for us to see later on. Okay. So the user will see this coming up on their screen, but the log file, it will say this on the screen, in the file instead. So that's something that we can do in our make file. Yeah, I'm going to just say that this is a possibility. I don't really use make files in this way, because once I start to get to this complexity of I want to be able to document everything that's happened in my workflow, I don't rely on the make to do it. I rely on my Python scripts. So in this one here, I wouldn't bother having this echo because this thing here is going to create its own log file that allows me to track it. I might do something like in one of the other lines where I'm just using grep or something like that. I might capture that to a log file, but anytime I've got a Python script, it's going to do its own logging for me. So what would happen if I ran a workflow that and make file that had all of these things implemented? Then at the end of the day, I'm going to see something like this that says the workflow was executed at this time and date. These are the things that I wanted to build, and then it gives me comments about each of them being built here. Okay. All right, I think, well, it definitely is. That's everything that I had to discuss today. So now is our final opportunity for questions and comments. A reminder that on Thursday, same time on Thursday, same Zoom link, we'll have a follow-up discussion session. So if you want to come along and ask further questions, you can. There's some potential topics here that you might want to cover. As with last week, let's go to the top. If I can get you to fill in a survey for me. I know people hate surveys, but I also understand why people love them. Even if you filled this in last week, if you can fill it in again for this week, that would be amazing. Just so I can see how we're doing. Given that there's only the two of you online, it's pseudo-anonymous as to what you say, but nonetheless, be honest. Yeah, well, if you don't have any other questions, thank you for your time. Thank you for your attention. Let other people know how much you've enjoyed this, if you've enjoyed it. And next week, we're going to have a topic which will completely break away from what we've been doing so far, which is accelerating your research. So we won't be reusing any of the work that we have done so far. We'll have a totally fresh set of scripts and projects to work on. And this will be really about how to make the most of the time that you have available to you. And ideally, without having to spend a whole bunch of time optimizing code. Because optimization is either fun or horrible for you. But either way, it takes a lot of time. So we're going to try and accelerate your research without doing any code optimization. So that's a topic for next week. Here we go. All right. See you later, everybody.